In this lesson, we are going to learn another method of factoring polynomials, and it is using the greatest common factor, or the GCF. Now, the greatest common factor is the largest factor shared by two or more terms. For example, the greatest common factor of 12 and 28 is 4. And there are two different ways that you can find what the greatest common factor is. Method one is you could simply list all the factors of each. So 12, we have 1 times 12, 2 times 6, 3 times 4. 28, we have 1 times 28, 2 times 14, 4 times 7. If you look, we do have a few common ones. We've got 1s that are common, 2s that are common, 4s that are common. But we want the greatest common one, and that would be 4. If you're really good with factors or if the numbers are smaller, this is a great method to use. The danger of this method is that you might forget the set that you need that gives us the greatest common factor. Method 2 would be to write your prime factors and then find all that are common and multiply together. So we use a factor tree. You break down 12 to 2 times 6. 2 does not get broken down any further. 6 breaks down to 2 times 3. 28 we break down to 4 and 7, 4 breaks down to 2 and 2, and we still have the 7. We circle what is common in both, and we multiply those together, and you end up with 4. So two different strategies for determining the greatest common factor. So what we want to do in questions like this is we want to factor out the greatest common factor. So we divide each term by what the GCF is. Then the polynomial is written in a simpler form to solve more complex problems. You should get in the habit every time you sit down to factor a polynomial by starting to see if you can remove a greatest common factor. That should be the first thing you ask yourself every time. Can I remove a greatest common factor? So if we look at this first polynomial, 16x squared y and 24x squared y cubed. Start by looking at your 16 and 24 and thinking about the factors. Use one of the methods if you need to. Ultimately, the greatest common factor of 16 and 24 is 8. When you are dealing with variables, the variable must be in both terms, and you take the lowest exponent on that variable. So there is an x in both terms. Both of them are x squared. So x squared is a common factor. There is a y in both terms. The first term has just a y to the 1. The second term has a y cubed. The lower of the two exponents is 1. So that is your greatest common factor. So we write that down. What we are now going to do is divide each term by this greatest common factor. And we're going to write the leftovers in the brackets. 16 divided by 8 is 2. The x squared cancel out, as do the y's. 24 divided by 8 is 3. The x squared cancel out. When you're dividing variables, you subtract exponents. 3 subtract 1 is 2. We are left with y squared. You can check your work by multiplying the 8x squared y back through the bracket, and you will end up with your original polynomial. So that polynomial is factored. Let's look at the second example. You look at your 7, 28, and 14, and you think about what is the largest common factor. Again, you might need to use one of the strategies for finding it, or you might know that 7 is the largest factor. Then you check your variables. There is an a in every term. A to the exponent 1 is the smallest that we find. There is a b in every term. Exponent of 1 is the smallest. So we divide each term by 7ab, but notice that 7ab still stays as part of your factor. 7 divided by 7 is 1. A squared divided by a, subtract exponents. 2 subtract 1 is 1. So we're left with a. B's cancel out. 28 divided by 7 is 4. A's cancel out, B's cancel out. 14 divided by 7 is 2. The A's cancel out. 2 subtract 1 is just 1. So you're left with a 2b. Again, you could multiply the 7ab back through the bracket by the distribution property, and you would get your original polynomial. Looking at C, 8 and 24. 8 is the greatest common factor. There is no variable that is in both terms. When you divide 8x by 8, you're just left with x. 24 divided by 8 is 3. There is your answer, 8 times x plus 3. Look at example D, 15 and 18. Your largest common factor is going to be 3. There is an a in both terms, there is a b in both terms. Exponent of 1 is your greatest common factor. 15 divided by 3 is 5, a squared divided by a is a, the b's cancel out. Minus 18 divided by 3 is minus 6, the a's and the b's each cancel out. Looking at E, there's one extra little thing with E. It starts with a negative. General rule of thumb is if a polynomial begins with a negative, we should take the negative out with our greatest common factor. So 16 and 24, 8 would be your greatest common factor, and we're going to take the negative out with it. There is an x in both terms, x squared is the smallest exponent. There's a y in both terms, y squared is the smallest. You do not have to actually physically write what you are dividing each term by if you can do it in your head. I simply do it so that we do not get confused. Negative 16 divided by negative 8 is 2. The x squareds and y squareds cancel out. 24 divided by negative 8 is negative 3. X cubed divided by x squared is x. And y cubed divided by y squared is y. Last example, 12, 8, and 20. 4 is your largest common factor. There's a c in every term. There's a d in every term. Exponents of 1 are your greatest common factors. 12 divided by 4 is 3. C's cancel out. D squared divided by d is just d. Negative 8 divided by 4 is negative 2. The c's and the d's cancel out. Negative 20 divided by 4 is negative 5. C cubed minus c is, or divided by c is c squared, and the d's cancel out. This is factoring by the greatest common factor.